This is problem 315. So with this one we have, says the unstretched length of spring AB is 3 meters. If the block is held in the equilibrium position shown, determine the mass of the block at D. So this is, I just redrew what they gave us in the textbook. The unstretched length of the spring AB is 3 meters. The system's in equilibrium, and they want us to find MD. So to solve this, where we always start is with the free body diagram. So I'm going to draw a free body diagram at A, particle A. We basically have the force of AB, force of AC, and then the force of AD. And we know some things about these. So we know some distances. So they tell us, so we know that it's 3 meters. This is like a 3-4, this is a 3-4-5 triangle because it's 3 meters up to the center point and then 4 meters over, so that hypotenuse would be 5 meters. And then the other one is 3 and 3, so we could do it one of two ways. You could just say, okay, it's 3 and 3, so it has to be a 45-degree angle. Alternatively, you could set it up as a common triangle, just 1, 1, square root of 2. So either way you want to do that. I wouldn't necessarily write them both on there. So that's most of our free body diagram. Remember, we also have to put the coordinate system. So we're just going to do x, positive x to the right, and positive y going up. And so now we need to do, sum of the forces equals mass times acceleration. Acceleration is 0 because we're in equilibrium. So sum of the forces in the x direction equals 0. So to do that, we can just go over here, look at the free body diagram. The FAC is going to be the negative x direction, so negative FAC, and we could do cosine of 45 degrees, and then plus FAB times 4 over 5. And that's going to, and then FAD is all in the y direction, so that's going to equal 0. So we know, let's see, we don't know FAB. We know that spring constant, and for FAC, we can actually find FAC. So FAC is going to equal that L minus L naught AB times that spring constant. This is actually the force of AB. Because they give us that unstretched spring length, and then we know the actual length as it is right now in equilibrium, and we know that KAB, so we can find that force of AB, which is one of the unknowns in that formula up here. So the length is 3 meters, or the stretched length is 5 meters, so that's a 3-4-5 triangle, so 5 meters minus that original length, unstretched length, which is 3 meters, and they just gave us that in the problem, and then times that K, that spring constant, KAB, which is 30 newtons per meter, and that was also given to us in the problem statement. So that gives us 60 newtons for FAB. So now that we know that, then we can plug that, go back up to this equation, and we can find FAC. So FAC is going to equal FAB, which is 60 newtons, times 4 over 5, divided by the cosine of 45 degrees. And so that will give us, just multiply it out in our calculator, 60 times 4 divided by 5. It gives us 67.88 newtons. And note that this would be the same. So we did the FAC times cosine of 45. We could also do FAC times 1 over square root of 2. We could use that common triangle. And if you remember, cosine of 45 equals 1 over square root of 2. But that's just another way you can do that angle. So now we have FAC. And so now we can go to the other equation that we have is sum of the forces in the y direction equals 0. And for that, we have that y component of FAC. So for this one, we'll use the common triangles just to show you both ways. So that'd be 1 over square root of 2 times FAC plus 3 over 5 FAB equals negative FAD. And so we have FAC, so that's 1 over square root of 2 times that 67.88 newtons, plus 3 over 5 times FAB, which is at 60 newtons, equals negative FAD. So FAD equals, I'm just going to multiply this out. Negative 84 newtons. So FAD, oh wait, oh, I did this wrong. Let's see. So we have the sum of the forces in the y direction equals 0. We get FAC plus that, those are both in the positive direction, minus FAD, and that equals 0. So I just did this wrong. So that means that FAD, when we pull that over, FAD equals all of this. So FAD equals positive 84 newtons because we have FAD pointed down. The reason I knew I made a mistake is because we know that the FAD couldn't possibly point up because it has that weight pulling it down. So it would be wrong. If you have a negative sign, then that would indicate that your free body diagram, you've done the arrow in the wrong direction. But we know it can't be going up unless it was a helium balloon or something. So I figured I had made a mistake. So now we have FAD. So now let's do a free body diagram just of that hook that was holding that weight. So we have that little hook here. And from that we have FAD, and we have the weight. So FAD equals that weight of D. So FAD equals the mass of D times G. So the mass of D, which is what they asked for, equals that F of AD divided by G. That equals 84 newtons divided by 9.81 meters per second squared. So mass of D equals, so 84 divided by 9.81. So that gives us 8.56. And let's look at the units. This is a really helpful tool in this class. So newtons are kilograms times meters per second squared. And then we're dividing it by meters per second squared. So we can cancel out the meters, we can cancel out the second squared, and we get kilograms. So M of D equals 8.56 kilograms. And if we check our units and they don't come out right, then that probably means we did something wrong in the formula. So that's a sign that you need to go back and check. And that's